So now we would like to bring our discussion to basic operators on values. Python, being a sophisticated calculator, naturally can perform the basic operations on arithmetic. So we have the plus, minus, times, divide. Not going to spend too much time here because you just type and Python will be able to do the right thing and even observe the right precedence, like 5 plus 3 times 2. It will do the 3 times 2 first, and so on. And then you have to the power of, this is done with a double asterisk, right? So 5 to the power of 2, 5 squared, that's 25. And then you have integer divide. So here Python distinguishes between integer divide. Once you divide, only get the integer value, versus floating point divide. Once you divide, even if you have integer divided by integer, you should have a fraction. It will generate a floating point value. So 1 divided by 7, you will get 0.1428, 1428, and so on. Whereas 20 divided by 3, you get 6. Yep, so it's one short of getting 7, so that's 6, and you will not have remainder. To get the remainder as an integer of the denominator, leftover of the denominator, you will do a percent. So 20 divide by 3, or we say integer divide by 3, we get 6, and 20 modulo 3, that's the percentage sign, will give us 6, because we are one short of 7. And then we have the usual comparisons, less than and less than equal. Less than equal, please pay attention. It is not the same as equal less than. All right, so you cannot spell it this way and expect Python to understand. It will not be valid. So it is less than equal, greater, equal, double equal means is it the same value or not? Versus exclamation mark equal means is it not the same value or not? So this is comparison. And these comparators will take two values and then compare, right? Is it less than, greater than, equal in value or not? Now notice the equal sign here. This is double equal, double equal. Double equal checks, compares whether they are equal or not, asks a question and returns a Boolean answer, true or false, rather than a single equal, which is actually an assignment. So be very, very careful of that, especially when you are doing your first few programs. You may be a bit not too confident about the difference, so be very, very careful about this. That usually leads to a lot of strange errors or bugs or mistakes that, if you're lucky, Python will stop you and say there's an error. If you're not, Python will actually quietly finish up everything, and you have no idea that you're getting the wrong answer until it's too late. Okay. Then this is left shift and right shift. You have to think about it like a binary number. Sort of like 5, for example, is 101. So if you left shift, it becomes 1010, and that means 10. So literally left shift means times 2. Except that when you times 2 by such a big number, it may drop off and the answer can be surprising. So if you want to times 2, use the times 2 rather than left shift. Left shift is typically used by programmers who are interacting with external interfaces, and for example robotics and moving arms and whatnot. Then you tend to want to do this. All right. And in special cryptography, we might sometimes do this too because of the efficiency and the clarity of this operation. Then right shift is the same. 5 is 101 divided by 2 and then rounding off, because we shift it to the right by 1 bit. It becomes 101 becomes 10. 10 is a value for 2. So 5 divided by 2, we get 2 in that sense. Assignment, we have seen it many times, and this is a short form for assignment with an increment. So x plus equals to 1 just means x equals to x plus whatever is on the right side. So same thing here. Y times equals to b just means y equals to y times b. The right side can be another variable. That's fine. Okay. So we have seen these, and let's look at some quick examples. I'm just going to copy and paste them over to my Python space. And yeah, unfortunately, it's not really complete. So I'm going to have to try to do this, right? I originally had some tabulations to align them so that they look better, but looks like it's all gone. Minus 2.2, right? All right, times 4. Um, divided by 5.1 to the power of 2. Then this is something like that. You see that along the way, we don't see any spider red flags over here, which means that we're doing fine. And at least on a preliminary scan, spider didn't detect anything that is not workable. Okay. Now, notice that we are looking at semicolon for the first time here. All right, semicolon essentially is a way to merge two or more short statements, short sentences, in Python sentences together. So here we are just saying A is assigned 1, and at the same time, not at the same time, but sort of in the same breath, we assign 2 to B, A plus B to C, and B raised to the power of B to D. And then next line, we have 2 assignments, P and Q, and we print out. All right, so the rest will be quite similar. So the semicolon really is not absolutely needed, except sometimes we just want better clarity, and having short assignments like A, B, C, D, E, all assigned with 1, 2, 3, 4, 5, that might occupy 5 lines on our vertical screen, which is really, really narrow. So we might want to use semicolon to save some vertical space, bunch them up horizontally rather than vertically. Okay, so here we are very quickly nearing the end of our demonstration of the basic arithmetic. And something new that we learned is to pack multiple lines into single line using semicolon. So let's just run it. Not surprisingly, we're going to see a bunch of calculations, right? And the numbers have been captured in the slide over here. So you can expect to see the values on the right hand side over here. And they should be the same as yours. Okay, so some values are producing integer, some are producing float. In general, Python is pretty tolerant between the operations of integer and float. Pretty tolerant, and for good reasons. We don't want something as naive as 22 divided by 5.1 to end up in error because 22 is integer and 5.1 is float, and Python will insist that you convert 22 to 22.0. This is really a bit too stringent. So for good reasons, Python is pretty tolerant. And also, Python is very attentive to the needs of high-speed integer divide and also remainder. So instead of asking us to share a single divide that might produce a floating point number and then rounding it, or else taking the integer part and dropping the floating point part. So that's a big waste of time because we are calculating the decimal place only to be thrown away. Python says you can do an integer divide, and I will just use a high-speed integer division algorithm, and I will not even generate the unnecessary floating point numbers since you are telling me you don't need them. So that is very good because for various calculations that are hidden in the background, such as checksums and cryptography and various communication needs, we need to do a lot of integer divides, and that is really, really helpful. And going along, we also have a bunch of operators that are designed to allow us to calculate, right, in a different way. For example, we have a Boolean arithmetic here. False and false will be false, true and true will be true, and so on. We have the bitwise ampersand and bitwise OR operators. So bitwise means they operate on the binary version of integers. So 5 has a binary value of 101. So that's 5. So 2 has a binary value of 010. So when you ampersand them bitwise, it means that 1 is to be ANDed with 0, 0 is to be ANDed with 1, and 1 is to be ANDed with 0. So end up we have 000. So that means 5 ampersand 2 will get 0. Then we have 4, right? 4 has got a value 100. Notice it's just 1 smaller than 5. Yeah? So 4 is 100 and 5 is 101. If we perform a bitwise OR vertically, that means 1 or 1, 0 or 0, 0 or 1, like that, we'll get 101, which is 5. So 4 or 5 is 5. And we have the XOR. XOR will be whenever you have matching ones and zeros. So let's just put down the numbers first. So 4 is 100 and 6 is 110. Whenever 1 and 1 they are the same, right, it will be 0. Right? So whenever it's different, 0, 1 or 10, it will be 1. And 00 they're the same, so 0. So that would be 010. So end up 4x or 6, we get 2. So why don't we just go ahead and try and run this. Okay. Just checking that I get all the copying done correctly. 5 ampersand 2. So the ampersand is bitwise. We need to stress that it is bitwise. Sorry, this should be a vertical bar. It is bitwise because of the calculations arithmetic done that way, rather than a logical AND, right? So a logical AND is of different meaning, which we'll see in a while. True and false gives us this. Okay, not of false, not false. Car, automobile. All right, we need to close the string here. Melon is non-citric fruits. Car is automobile. Car is automobile. Apple is not melon. Apple is not melon. 5 in this, 5 in 3, 5, 7. Right. So we are looking at a few very interesting operators that perform arithmetic on strings and values that are, rather less intuitive to a beginner. But hopefully in time, you should find that it is actually rather basic, rather intuitive. And then you would have gone past the